Hi again. Yeah, so let's welcome Kristina Trofimova giving a talk on LLM Gradle converter.
I'm actually surprised how many people are still in this room.
There are still pizza left.
That's true. My talk will be centered about LLMs and all this hype train that is going on. In comparison to Andrei's presentation, I will concentrate more on technical details of my research. So let's get it started. I believe that at this point, everyone is familiar with the large language model terms, so I will not even explain it, I believe. For example, it's ChatGPT, BART AI, and even AliExpress, Alibaba has its own AI chat assistant now. So what's Gradle? Also pretty popular thing. I believe everyone who's ever touched Kotlin is familiar with Gradle. It's a build automation tool for multi-language software development, mostly used for GVM languages. And in August 2016, Gradle team announced that they are supporting Kotlin now. And at the moment, Kotlin is more preferred in comparison with Groovy, which was initially used for scripting Gradle. Because of the features that Kotlin supports, for example, it has static typing, so it's more about type safety and all this stuff. It's also more IDE supported. It's more supported by IntelliJ IDEA, for example. So it's believed to be more readable, for example. So despite of all these cool features, no one really wants to migrate. Why is it like that? Also, again, if you've ever dealt with Kotlin and Gradle, you know that if you're working on a big Gradle project and you have some kind of issue, you just fix it, don't think about how exactly you fixed it, and you just keep going with your work, because it's a pretty unpleasant experience to fix Gradles, and it's even more unpleasant to actually migrate from Groovy to Kotlin because of how complicated build scripts might get. This slide was to just illustrate how complicated the system can get with multi-projects and some source directories and all this stuff. So maybe there are some kind of existing automated solutions for migrating. During my research, I found only 2 open source solutions. One of them is Gradle Kotlin Converter. It's a CLI open source solution that is based on determined regex substitutes, and I tested it, and during my benchmarking process, I found out that only 23% of projects actually convert successfully, and then I say successfully, they just build successfully after conversion process. Another tool is Gradle Updater. It's IntelliJ IDEA plugin. It's based on PCI internal tools of IntelliJ IDEA code analysis. And first of all, there are no updates since the end of 2022. And second of all, it also uses determined mechanic substitutes. Unfortunately, I was not able to properly benchmark it because it's an IntelliJ plugin, so I can't really write a script that automatically benchmarks the solution. But we believe that it's also not that effective because of this mechanic trivial substitutes. So our approach is a LLM-based conversion with validation of generated code with the internal tools of IntelliJ IDEA. So the pipeline is pretty straightforward. We just have Gradle project, then we do LLM-based conversion. After that, we evaluate with this code with internal tools of IntelliJ IDEA, and then we get Kotlin Gradle project as a result of our pipeline. With more details for the pipeline, first we have benchmark collection. Obviously, we just collect all the projects we will benchmark on, and then we convert all these projects, get Kotlin Gradle projects after conversion. Then evaluate all this generation code, and this feedback we further use to make the conversion even better with this infinite loop of bettering, I guess. So the first step is benchmark collection. For that, we use a Big Code Web. Big Code Web is an internal tool of JetBrains that analyzes open source, not open source, but public repositories on GitHub. For the project, we collected projects that use Kotlin. They are not left behind, so the last commit is relatively later than the 1st January of 2023, plus 100 stars, and we are using Java 17th Java in this version because it's turned out during the project it's the most popular Java at the moment. So out of 1,648 projects, I selected 341 projects to benchmark on.
Based on what?
Huh?
Based on what?
So these parameters, and they just build successfully after like basic manipulations, for example, check out on the release commit. Mm. So I will talk about this right now. It sounds relatively easy to just clone repositories and all this stuff, but if you ever build open source product, you know the underlying problems. For example, just out of the box, not all the projects have any kind of buildable version, no release commits. Some of them use internal libraries I don't have access to, so they're not buildable. Some of them want to access some kind of server that I don't know about. Some projects use really old versions of Gradle that don't support Kotlin. And I also, during this step, I had unexpected RAM leaks from Gradle daemon processes and other unexpected Java processes from Gradle builds. When we are done with benchmark collection, it's time to do LLM requests. And in this project, we use LLM as a black box, but despite of it being used as a black box, there are still a lot of parameters that heavily influence the successfulness of conversion. For example, the general selection of model, as I said before, there are plenty on the market at the moment. Prompt engineering is a crucial thing in terms of getting helpful answers from ChatGPT, for example, temperature of model, and a number of conversion tries per project. There are also parameters that are not directly related to the LLM parameters, such as the exact type of conversion we are doing. In this project, I'm doing only top directory conversion or full conversion that mocks full migration process from Groovy to Kotlin. So with the first and fourth parameter, OpenAI ChatGPT, obviously, I'm using it with Gradle CIP, state-of-art solution on the market. And the number of conversion tries per project is 5. It's just from my research intuition, I guess. I just got it from my mind. Speaking about prompt engineering, just a basic prompt with general instructions. First, you again given a sequence of requests. Please convert from Groovy to Gradle, following the rules. Then the rules, some of the rules have examples. And then the script in the triple backticks for the model to understand where the actual code is. The temperature of model is a parameter that controls the randomness of the model's output. The higher the temperature, the more random and creative model gets. And default ChatGPT temperature is something about 1, maybe a little bit lower. And in terms of my research, I assumed that we want less random and more deterministic outputs. So I just chose 3 values I will benchmark on third there.
So, may I ask a question? Why don't you have like default value of ChatGPT among your test values?
Default value of ChatGPT temperature is something next to, nearby 1, but it's actually lower. It's 0.9 or 0.8. So I just assumed that 0.8 is a default value, something like that.
Why not go more creatively?
As I said, I just assumed that. So first, I benchmarked on just the default value, and it turned out that model gives this basic ChatGPT mistakes, such as using non-existent functions and using non-existent variables and all this stuff. So I just assumed that maybe it's better for the model to give more deterministic answers, because we want to avoid these random, non-existent functions, variables, and all this stuff. So the type of conversion, we are talking about 2. First, just simple root conversion, just to begin from somewhere. We are choosing top directory script and convert it to Kotlin. And the result we are aiming to is a full conversion, meaning all the scripts from the project are migrated from Groovy to Kotlin, like in this picture. So for the default temperature, root conversion is almost 58% of successful builds. And for the full conversion, it's almost 15% of successful builds from scratch, meaning you don't have to do anything with the outputs, just to build it. For the whole set of temperatures I have, the results for full conversion are like that. Yeah. So, conversion problems.
I'm sorry. Why don't you have numbers for this root conversion on all temperatures?
As I said, I used root conversion as a thing to start from, but as we are aiming to do full migration, the rest of the tests I've done on the full projects.
Okay.
Conversion problems. Kotlin and Groovy might behave differently in some cases. For example, a visibility scope of extra variables are different. Syntax errors, as I said, non-existent system variable names and functions, and usage of Groovy syntax in Kotlin scripts. And the most tricky one is the quality of ChatGPT answers differ from time to time and depend on OpenAI updates. So if in December 2023, overall OpenAI ChatGPT answers are shorter and less precise, my project heavily depends on it. I talked to the Gradle team, and they told me there is no way of avoiding it at the moment. So I just depend on the quality of overall OpenAI ChatGPT answers. So we've got a buildable Kotlin project. How we can be sure that they are similar, they are identical after the conversion. So if you've ever used IntelliJ IDEA, you know that it analyzes code basically and has some awareness of your project. In my project, we are utilizing it to extract project model via Bcode plugin. And we are extracting something like that. So it's project data with all the modules and all the libraries we have in the project. Why we are using Bcode? It's just because it's easier to benchmark. Bcode can be run in headless mode in comparison to IntelliJ IDEA. So, more particularly, if we have some kind of Kotlin Gradle project, we get somewhat like that structure of data nodes, and we just flatten the structure, extract all the parameters we want to compare, dump it into JSON, and then compare. That's it. So the numbers with comparison are like that, but I would not trust them because this step is not fully done yet. The comparator I have at the moment is pretty weak, and I have a lot of issues with Bcode. So, project model-based evaluation. Current state of things is that for the evaluation part, like more sophisticated than the thing is just buildable, we don't have a lot of runs, primarily because for the projects to be evaluated in this way, we want to have buildable projects. So it means I'm a little bit stuck on the LLM conversion process in terms of bettering it to at least to get better results, to be actually able to evaluate things at this step with more precise comparator. Current comparator is likely to be not precise enough, and I faced a lot of Bcode issues. The problem is that Bcode is an internal plugin that is currently frozen right now. So big code might be unable to analyze some projects. So it means they either time out or it doesn't perform well correctly. And also big code only supports Kotlin project analysis at the moment. And yeah, there is just few people to fix these issues because of the plugin being frozen. So further plans on this step are more runs with more projects to benchmark on, a more precise project model comparator, and further investigation on Kotlin and Groovy-based project models differences. Yeah, and this is further steps and perspectives on the whole project. Better prompt engineering, there is no perfect prompt in this sense. Investigation of temperature influence on code conversion process, more precise project model comparator, utilization of other available LLMs, and maybe integration to IntelliJ IDEA as a feature or a plugin in the further future. That's it.
Actually, I have a question. I didn't really fully understand how the full migration works. So you start with root file, and then like in which order do you give to ChatGPT other files to migrate?
Yeah, that's a good question. I just forgot to talk about it. So the full migration goes like that. We go from top directory to the bottom directories, keeping the context of the chat. So first, ChatGPT is given the root build script, and then the second level build scripts, then and so on and so on and so forth. And all the previous conversions are stored in the same chat for the model to keep the context of conversion. That's
Okay, thank you. And didn't you try to somehow also add even more context? For example, you can maybe add a list of directories, like list of files and directories, and all this stuff to ChatGPT. Maybe add other files also, because like I remember some complicated projects where like there is some build.src folder and there are also dependencies between build files. And maybe if ChatGPT will see like more of them, more of the information at the same time, maybe then it can like perform better.
So if we are using ChatGPT 4, it's all about the expensiveness of the process. So at the moment, the thing is the benchmark collection is already extremely slow, and if we are adding more context, it will be even slower. But it's a good idea. Like experimenting with the context is truly a great idea in this project, but yeah, there is like a variety of parameters I'm not considering at the moment, and it's just all about choosing the right ones and keeping like the priority list of what.
And also, speaking of like complicated projects, you showed us some numbers and benchmarks. And have you like checked which projects did it successfully like manage to convert? Were they like simple ones or a bit more complicated? For example, like I wonder if it can really handle like some build.src directories or something.
No, I can't handle build.src directories at the moment, and it's a big issue. Like it's one of the most popular reasons why projects are not converting.
Okay, makes sense. Thank you.
So yeah, and in terms of root conversion, for example, yeah, obviously more like simpler projects are easier to convert. Root Gradles often look like just bunch of plugin declaration, for example, and this thing is easily convertible in comparison to something more difficult. Yeah. Looking for. Thank you.
Speaking about context, have you ever considered adding some information from project structure? For example, consider switching from Groovy to this ideas Gradle structure, like parsed, PSI, something like this, or somehow adding it into the context.
No, again, it's I didn't try it. Yeah, but I was thinking that like somehow playing with the context will be helpful. There is also an idea of inserting, the details we extracted from the code itself, and yeah. I was not looking in the direction of the context almost like at all.
I have one more question. Andrei showed us that it can be useful to use some predefined methods, like to make some conversions, make some work. Like, for example, Andrei uses some predefined commands that we can try to put into the host, so like to make completions. Like, user can define them, so they're like written already. So in your case, it will be just, as you showed us in the beginning, another tool that's from IntelliJ, I think, that also tries to convert one file to another file, but with some heuristics, like with some predefined methods, not without like LLMs. So maybe you can also try to do some parts of work with predefined methods, not with LLMs, and then.
Sure, as I said, there's plenty of things you can try in this problem. But it's easier to do in Andrei's situation because he's working with, Lambda languages. I don't know how it's called. And there is also a problem that if you partially convert it with, regex substitutes, you have like incorrect code in between what exactly you want to pass to the ChatGPT as a request.
Maybe we can possibly this code and say like, okay, it partially converted, like finish the conversion, and you can make it like in parallel. Like you don't really need to do only this thing. You can still like continue with your approach and also try to make this request like as a second one. Maybe it will be like more successful.
Maybe, but I don't really know.
Yeah, it's just an idea.
Other questions?
Do you have any examples of where the converters, the open source converters which you started with, failed, but your approach succeeded? Like, can you describe them? What was different about them?
Not really, because I have a bunch of projects and I can't, I have to search for extended period of time to just show the example. And I'm afraid that unfortunately I'm not able to answer this question.
Why I'm asking is that I know that LLMs don't understand regexp at all. They cannot use them. But I imagine it must be a good idea to combine the two approaches. So you try to convert with those converters, and on the things which fail, you can try to push the LLM to do that.
I was thinking about that, but it just doesn't come together in my mind because do you want to, like as I told Gleb before, do you want to pass like partially incorrect input code to the LLM and just say fix it? Maybe it works.
As an option.
Yeah,
Maybe those regex can be incorporated into the prompts which you use. maybe something else. But you need to understand what are the issues that the converters have.
Yeah, I was mostly focusing on the issues that my conversion has, and tried to better the process with prompt engineering, but maybe your approach will work better.
Can you provide an example of what change in the prompt was?
Yeah, it's for example, if we are just converting with the first part of the prompt, where the prompt is, first part of the prompt, just convert this to that. ChatGPT tends to rename variables in camel case. Because it's like, the thing that we use in Kotlin. And you can just tell ChatGPT, first rule, do not rename any variables. Yeah. Or with extra variables, I just give the example of how exactly it should be converted. So, yeah.
How many rules do you have in those prompts?
I have two options of the prompt at the moment. So I actually tried to somewhat combine the open source solution with mine, with prompt engineering. So I just took all the examples they had, like they have a table of substitutes, and I tried to just combine them with the rules I had. And this one has like 22, and the basic one has 10.
Okay, all right.
Other questions? Okay, then let's thank Kristina.